you can do with variables, you can do self-referencing like that and assign them to themselves. So end if, that's all that we need to do there. And loop, because we're done with the loop. And then at the end of that, we need to start assigning it, because this for loop will get executed completely in its entirety. So after the for loop has counted everything, we want to assign it to our output. So we're going to say counter out is going to be count. So now we've assigned what the counter out will be to our count, which allows us to put the total number of ones on our output. And we also are going to change our state back to waiting, because we're done. So my state is now equal to waiting once again. Okay. Now we can close this block, end if. We can close this big block, end if. And then we can close the process statement. So end process. Finally, we can assign out to the output what's happening. So again here, we're outside of the process, which means that everything within where we're working will be assigned concurrently. In other words, all at the same time. So the process will do what it's going to do, and then this output will get assigned concurrently with that. So we're going to take our counter out, which was the result of our counting to see which bits were turned on, and we're just going to put it on the output. Now we can close the entirety of the block, so we'll end behavior. Okay, and that's all there is to it, so pretty simple, right? Okay, let's save and compile. And whenever you save a VHDL file, make sure that the name of it is the same name that you save the file as. So for counter needs to be for counter here. Okay, save. So let's hope this goes to plan. Once again, things can take a little while to compile. And we have errors, which is unfortunate since I just typed this from the exact same thing on a different computer that I was working with. Okay, let's see what we have here. We have a typing error, so that is taken care of. And these should all pretty much be because of that. So try again. And more errors. Okay. Welcome to the joy of Quartus. Okay, so we have an end if there, and I'm missing a semicolon, which is probably what's doing everything. End loop, end if, end process. Okay, try this again. Third time's the charm, right? And it's complaining that project 3 is undefined, which means that I didn't set this as the top level entity. So all sorts of problems that you might run into doing your project. And hey, what do you know? Analysis and synthesis was successful. Great. So we know that this compiles now. So we're going to turn it into an actual block. So we're going to just right-click on it, create symbols for current file. It'll go through and compile things again, and yay, we've now created a symbol. So let's plop it down onto something. Creating a new file. Can make a block diagram again, and we're going to plop it down. So there she is, project 4 counter. Kablam. Alright, now let's hook it up to some stuff. So we're going to go into here and grab some pins. A couple of input pins would be cool. And an output pin would be cool too. Alright, let's name them. Okay, so we'll call you input. And you are 15 down to 0. And you're just going to be our clock. And you're going to be our output. You're going to be 3 to 0. Okay, and remember you have to use the thick line for ones that have more than 1 bit on them. So for there and there. And you use the thin line for things that are just 1 bit. Like our clock. Okay, now in order to do our simulation, which is what we're going to do later, we have to compile this again. So go into your files. We'll save this guy first, so project 3 is a perfectly good name. Remember to right-click and set it as the top-level entity, and then we will compile it again. Everything's good to go. So now let's do some testing with it. Let's create a new waveform. So we have vector waveform file down here. And we'll right-click and we'll find all of our pins. So we go to Node Finder, and we'll list everything, and we'll grab the clock, our input, and our output. You can see here that it has listed out every single input pin and every single output pin, but if you just grab the name, it grabs all of them at once. So we'll say OK. We want our radix to be hexadecimal, so everything will show up as hexadecimal. There we go. Now we need to start actually putting some simulation on it. So I'm going to right click on the clock here, I'm going to go to value, I'm going to go down here to clock, and I'm just going to give it a period of 5 nanoseconds and a duty cycle of 50%, starting at 0 and going until the end of time as far as Quartus is concerned. And there we go, our beautiful clock that looks way better than my Microsoft Paint. Okay, and then here on the input we need to also simulate a few different cases. So I'm going to put some different bits on it. So I'm going to go to arbitrary value here, and it'll ask me a start time and an end time. So I'm going to take it to, remember to change this to nanoseconds since we're in nanoseconds. And I'm going to take it to 20 nanoseconds. That's completely arbitrary. I'm going to change the radix here to binary just so that I can show you guys what's going on. And we'll give it 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so there are 8. And it's saying, do I want to change the radix? Yes, I do, because I want to see what it looks like in binary. Okay, and right here, I'm going to do some more arbitrary times. I just double-clicked on that, and it starts there. So end time, we'll make this, say, 40 nanoseconds. That sounds like a good one. And we'll give it just 4 bits at the very beginning. So 1, 2, 3, 4, 0, 0, 0. It'll correct that for me. A little bit. So now what we have here is we have 2 different inputs. We have 8 ones here, we have 4 ones here, and then we have 0 until the end of time. I'm also going to change my output radix a little bit. So instead of showing up in hexadecimal, we can have it show up, say, in decimal instead. So it would be our normal, 0 through 10, 0 through 9. Okay. So now we've created a simulation for it. Let's save our file and let's do some simulating. So we'll go down here to our simulator tool, and we'll go to functional. Since we don't care about the timing again is has all those gate delays like it would in an actual circuit. The functional simulation is just what will happen. So we have to generate a simulation netlist. After that's successful, we can hit start. And we can go to the report here. Okay, so what you can see here, and let me give a little bit more space, is exactly what happened. So here the first clock comes in and it's in state waiting. So now it starts working. So through here, it's now moved to the working state. Or excuse me, it's moved to the working state in here, and then by the time it gets to the end of the clock here, we have assigned the value of 8 to it because it's now counted everything that's going through it. So nothing happens. Grab this guy. So nothing happens, nothing happens. Now we've changed the input, but nothing's been clocked, so nothing happens until we get to here. This is when it starts working again. So we're in the working state, working state, working state, and now we're done, which is why the value changes right here. So again, the finite state machine changes on every time that there is an uptick and something happens. So for this rising edge here, something's changed, but it takes an entire clock cycle for that to be shown in the output. And that's that signal line again. So a signal is going to change every time that we have a clock. It changes on the event there. So it gives us a little way to have persistent memory. You can see here that that 8 has lasted all the way through until we put a new input on it and we gave it the rising edge of the clock. So there are all sorts of things that you can do with finite state machines and events and just simple clocks like that. So I hope this has been helpful for you. Again, if you have any questions, feel free to email me. I'll be happy to answer whatever I can. And we'll see about doing a few more tutorials, and then you guys will be off on your own. So again, thanks for listening, and I hope this has helped.